Uh, In our system, or in our topic of looking at the body coordination, we first looked at the various systems that are in the body. Then we looked at how the nervous system controls the body and gets the systems to work. We'll have a look at the chemical control, especially at hormones. Now, hormones are what control many functions in the body, and they are essential. They are essential, and they are produced by the endocrine system. The endocrine system is a communication system that looks after the internal environment of the body, energy levels, water, and those sort of things, the temperature, and the body goes through the changes that we go through. These are all handled by hormones. Now, hormones are produced by the endocrine system, and they are located, the various glands are located all around the body, as you can see in figure 7.31. Hormones are produced by the endocrine system to cover various functions in the body. So the glands that you have, thyroid glands, pituitary glands, the pancreas, adrenal glands, ovaries if you're a female, the, the testes if you're a male, you can see where they're located and what function they do. Hormones are only produced in very small amounts. They're not large amounts, but they have a specific job that they do. As we said, the chemical messengers are the hormones. They are secreted in very small quantities and travel through the bloodstream to all parts of the body. And we need to be aware of that. We know that the bloodstream, the blood carries oxygen, carries everything that we need to each of the cells, food, oxygen, and also hormones. So the circulatory system carries everything that the body needs to every cell. When we looked at enzymes, we saw that they have a specific structure and they lock onto, like a jigsaw puzzle, they lock onto a certain lock and key model. This is the same in hormones. So hormones are only needed in very small quantities to have an effect on the body. They regulate that they regulate functions like growth, water balance, regulation of glucose, and sexual development. Often in the teenage years, our hormones are out of balance a little bit, and eventually they come back into balance at the end of the teenage years. Systems working. The endocrine system is coordinated by the pituitary gland, and you can see where it's located. Doesn't want to let me go down there. There we go. At the base of the brain here. Two parts of the endocrine system, the hypothalamus and the pituitary gland that attaches to it. These are located deep within the skull where they are well protected. Obviously need protection. Systems working. The endocrine system is coordinated by the pituitary gland. Doesn't want to let me move this, which responds to information from the hypothalamus. The hypothalamus is a portion of the brain, and you can see it in figure 7.33. We've had a look at that there. Right. It checks the internal environment, checks your body, the internal environment, an automatic system, and if there's anything wrong, right, or those conditions change, then the hypothalamus responds. Most important function of the hypothalamus is to link the nervous system and the endocrine system. It secretes or releases hormones that act on the pituitary gland. This is often called the master gland because it controls the glands other glands of the endocrine system. If we have a look here, these other glands are controlled by that. So we remember that's why it is. Let's get rid of that. Let's have a look. It doesn't want to let me go. Let's have a look at this 7.32. Hormones are only active in cells where the shape of the hormone and the shape of the receptors fit together, like pieces of a jigsaw. So they're coming through the bloodstream, just like enzymes, and they only lock onto the shape that they are made for. So we see that. So I'm going to let you do that. Do that. In situations of fear or stress, both the nervous system and the endocrine system have roles to play. And you can see this in figure 7.34. This is known as the flight or fight response. Adrenal glands, the fight or fight response. Blood glucose levels also rise to provide muscles with the required energy. The nervous system acts swiftly through the network of neurons to work with the endocrine system to increase the rate of breathing and the heart rate. So we see that it's essential that the systems work together. Let's have a look at 7.35. A reverse cycle air conditioner maintains a preset temp in a room by heating or cooling the air in response to the temperature detectors when it's on automatic. So if the temperature of the room goes above a certain temperature, the air conditioner switches on and cools the room down until it reaches the set temperature. So your body actually responds in a similar way. It has an automatic setting, something that we don't consciously do, and that's done automatically. Digestion, growth, repair, respiration, and the manufacture of hormones are some of the chemical reactions taking place inside our bodies. The heat they produce as a byproduct maintains the body temperature regardless of our surroundings. So we know that as mammals, we maintain our own body temperature, and this is how it's done. Move across and have a look at this 7.386, I should say. Your body temperature stays the same. We know that, and that's done by the hormones. Okay, one of the most important examples of homeostasis is the regulation of the body temperature. Not all animals can do this as a normal bodily function. Animals that can maintain a consistent body temperature, such as birds and mammals, are called endothermic. We know that, and those that can't are called exothermic. We know that from year 7, year 8, and also earlier in this section here. So we can see here we've got a contrast here. We've got a lizard, which is ectothermic, and see that it's outside temperature, or the temperature of the outside, its environment controls its internal temperature, and the mammal, the bilby, is endothermic, so body temperature, which is similar to us. We know that ectothermic animals lie around in the sun because they need the environment to control the body temperature, and that's why they go less active in the winter months, because they don't have that control of the temperature. And if you get cold, obviously you're not feeling like moving around all that much. So let's have a look at hormonal control of the temperature. The hypothalamus acts on the pituitary gland. That's something that you need to know, right? Control the body temperature through the thyroid gland. The hypothalamus receives information from the receptors in the skin, as seen in 7.39, and including the hypothalamus itself also. If the hypothalamus detects a fall in your temperature, it produces a hormone that causes the pituitary gland to secrete more thyroid stimulating TSH to release hormone thyroxine. Thyroxine travels in the blood to all cells and causes the rate of metabolism in the cells to increase. So increased metabolism, that generates more heat and warms us. So it's happening without any control or any sense of us controlling it. See that it's happening back here. Now, here, 7.39, the skin has many receptors, and we can see how they work. Many receptors on the outside here, and picking up changes in the temperature, and we can see there's sweat glands, and we can see where the epidermis is, the dermis, and the fat. And this is done in a chemical control of your body temperature. Now, obviously, your endocrine system, the temperature when you feel that, better see what happened. Not sure what happened there. The page went missing for some reason. Here we are anyway. So when you feel cold, you can feel it on your skin, right? Right. There is also the nervous control clocks in as well automatically, right? Because it's sending messages. There's movement in the muscles, shaking movements extend to the large muscles of arms and your leg, and you begin to shiver. Shivering increases the amount or the activity of your cells, and this creates heat and raises the body temperature. This is the body's way of creating warmth by using energy. So the nervous control has an aspect to it as well. This nervous control has an aspect to it as well. Another aspect of the nervous control is that it reduces blood flow to your skin when you are cold. And you can see your skin, feel it. You can feel your skin shrink a bit when you are cold. It reduces blood flow. The narrowing of the blood vessels near the surface of the skin. You can feel that. You can feel it. And if the external temperature is very, very low, blood flow to the fingers, toes, nose, and ears is reduced further, and you can lose feeling in them. This causes your toes and fingers to go numb, and that often happens in the winter if you're outside, you haven't got gloves, you can feel your, people will say, I can't feel my hands, it's so cold. It's so cold. So when the hypothalamus then sees that it's on automatic, of course, so it sees that there's a rise in the temperature, and nerve messages are sent to the sweat glands and blood vessels. Blood vessels close to the skin dilate. That's mean they get bigger, and this allows more blood and carries heat to the skin surface. Okay, the extra blood near the surface makes your skin too red, and also you start to sweat. The sweat glands, they kick in. So you can see that there is nervous control of what we do, as well as the chemical control of the functions in the body. So in this way, the systems are working together. What you need to remember is that you're looking at hormones. The key hormones should be able to look at, say, what these hormones are, what they are, and what they do. Should be able to show where the glands are. You should be able to say how the system works, all the systems work, and also to show the, just like that, to show where the, how the hormones get there, and what the receptors and the lock and key method that we spoke about. Also the flight and fight response, and a bit of an idea of how the internal body temperature is controlled. You should know that, controlling the body temperature, and an analogy that is valid. The analogy is with an air conditioner. Okay, so you can see how it picks up, it receives information from the environment and then controls the internal temperature or the temperature. And in a similar way, it's an analogy for how the body controls temperature, because we are endothermic, not exothermic. Some you should be able to, if there's a graph, you should be able to say which animal would be endothermic and which would be ectothermic. That's standard. You should be able to give us, or be able to understand hormonal control of the temperature, which glands do it, how they do it. Should be able to do that, and also then be able to link that in with nervous control, to link both the skin receptors here, and be able to show how that works and how it is able to, the nervous and the endocrine system work in together to control the body temperature.